So if it's equal to, it's solid.
If you have the or equal to, that line underneath, if you had the line underneath, the or equal to, it will be solid. This one doesn't, so this one's going to be a dashed line. So just, keep that in mind. Your calculator will remind you as well. And now the next step is, how do I graph it? All right, we got a graph and then shade. All right, graph and then shade. All right, here we go. You have it, so why not use it? Let's grab your calculator. Go to Grapher on the calculator for me. Go to Grapher. I'll do this nice and slow here with you. All right, we don't even have to, we can just type it in as is. It doesn't even have to be in y equals form. So ready? 3x minus 5y. Where's the y? There it is. Everyone just catch up, please, so we can talk about the inequalities. All right, the inequalities without the or equal to. The inequalities without the or equal to are located above, right where the square root is and right where the x squared is. So we're looking for less than, so I got to go shift that square root key. And we'll put it in there. I'll show you where the or equal to one is when we get to it. And then 15. All right, you ready for this? Go ahead, plot the graph. Ridiculous. Okay, it even shades for you, and if you forget it's a dashed line, it's right there. All right, but I do need to see some type of work. So what you're going to show me on the paper before you graph it is you're going to write down what the two intercepts are for me. And I'll show you what I mean here. So you got to write down what the intercepts are. The x-intercept and the y-intercept, where they cross the x and the y-axis. And that simply can be done by just dragging your cursor over to where it hits the x-axis. Now it doesn't call it, if you take a look, everyone see down below, it doesn't call it x-intercept, it calls it a 0. We've called that in the past. So it's 0, 5, 0 is one of the intercepts, along with, now scroll to the y-axis for me. It literally says y-intercept. Can't miss it. There it is, y-intercept, 0, what's that one? 3? I got it blocked, -3. So I at least need you to write that for me. All right, because now the graph's going to do everything for you. All right, so make your own XY axes. Just a quick tip. Don't make the axes until you find the intercepts. All right, because you want to make sure your intercepts fall on your axes when you put them in. All right, so find your intercepts first. Don't put the X and Y axes there until you find them. All right, here you go. Ready to roll. Just make sure you got 5 on the X and -3 on the Y. So 5, 0, 1, 2, 3, 4, 5. Graph it. And 0, -3. Graph it. Grab your straight edge. That's why you have one. Grab a straight edge. And just remember, it is dashed. It is dashed. You have two different ways to remember it's dashed, right? You know it. Bless you. And the last thing you need to worry about is the shading. And I don't even have to teach you how to shade, how to remember where to shade. There you go, above the line. All right, usually I'd have to go over, we got to test a point, see if it works. Not anymore. All right. So any point you pick in the shaded region is an answer to that inequality. Anything you want to ask before we up it to 2? Okay, when we go 2 now, do it one at a time. All right, because it's very hard to tell, for me anyway, if I type both in at the same time where the shaded region, where I need to shade. All right, so I'm going to tell you do it one at a time, just like we did. So start with 2x minus 5y. Solid or dashed? Solid, yep, because now I have the or equal to. And I'll just stay with me. I got to show you where that key is. All right, and then you show me the intercepts. All right, everyone ready for this one? Because you have to get that key somewhere different. All right, so let's type this in here. 2x minus 5y. All right, everyone, if it's the or equal to one you need, it's under the toolbox. All right, the or equal to inequality is underneath in the toolbox right here. And it's the first two there. All right, and we need what here? Less than or equal to. There it is. 10. Graph it. And see where your intercepts are here. Zero, -2. And then the x-intercept. Again, it calls it 0, 5, 0 again. All right, throw it on the graph. Solid line, remember, please? Solid. And I am asking you in kindness as of now, because I'll get on you if you don't, please use your straight edge, right? Because that's going to be key to this, to the last problem we do today and overall. All right, please use a straight edge when graphing these lines. And where are we shading this? Above, right? Yep. Now I'm going to do the same exact thing for the next one. When you shade for this last one, everyone, when you shade for this last one, this is why you have multiple colored pencils. Grab a new colored pencil. I want the shading to be in different colors, and you'll see why if you don't know already. This last one, solid or dashed? Dashed. Go ahead and find your intercepts for this one. And where are we shading this one? Nope. This one's below the line. Anybody look it up yet? Below the line? Going or to the right of the line, I should say. All right, there's two things I'm missing now. After I do all my graphing and shading, there's two things I'm missing. When you graph two on the same piece of graph paper, I need to know where the solution is. The solution is where they intersect each other. So I need a big, bold, No doubt in anybody's mind where the solution is S, where those two shaded regions overlap. So wherever the two shaded regions overlap or your colors intersect, I need a big S there, because any point you can pick there is a solution. And I'll leave this up to you guys. What's the other thing you think I need? A label, at least one. When you put two lines on one graph, you need to label it. I don't need both labeled, I just need one labeled. So 2x minus 5y less than or equal to 10. And I don't know if anybody's tried it, but go ahead and graph both lines now in your calculator. Hopefully you can see this area is where the two overlap. What does that look like? Just humor me here for a second. Oh, look at that butte. There it is. Sort of been a game changer freshman year, huh? All right, ready? Any other questions? Okay, next up, a little different type. Is everyone good with their shading? All right, yes, you can use your calculator for this. I'm gonna go a little bit quicker. For both of them actually, solid or dashed? Solid, right? They're both solid. When it is just X only or Y only, it will be a horizontal or a vertical line. Okay, Y only or X only, not combined in the same one. X only or Y only, it will be a horizontal or a vertical line. You guys can go and tell me right now. For X is less than or equal to 2, what type of line do I end up having? Gabby, what do you got back there? That is a vertical line, yes. So anytime, you don't need your calculator to tell you, but anytime you see X by itself, it is a vertical line going through that number. So we are going to have a solid vertical line going through 2 on the x-axis. So we have a solid vertical line going through 2. Shading, where are you shading this bad boy, to the right or left? All the x is less than 2, yep, and your calculator shows you, but we are going to the left with the shade. And then anytime it's y equals a number, it'll be horizontal. No intercepts needed. Through -1 on the y-axis now. Horizontal line going through -1 on the y, yep. And these are all the y's greater than -1. You can look on your calculator too where the shading should be, but we're going up. Should be going up from the horizontal line. And then last thing, a nice big S where the shaded regions overlap, because that's your solution. And one last thing, label one of them. Yep, label one of them. X. How are we feeling, all right? Ho, 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 ho. We've been on easy street till this one. Or I thought everyone was just gonna automatically just grab the calculator and start typing like you're texting. No? Okay. Let me know how that calculator works out. Well, undefined error. Yeah. Oh, you can't use it for everything, huh? All right, look at this right here. What's going through your mind? Just throw out things that are going through your mind just based on what this looks here and what we talked about today.
X is greater than or equal to -2 and less than 5.
Yep. So what type of lines? What are we talking about here? Throw something out. What should this graph look like?
Dashed and solid.
Oh, wait. 2? Yeah, we're going to have 2 lines here. One's going to be solid. One's going to be dashed. And it's just x equals, right? So what type of line are we talking about? We have 2 lines. What type of lines are we talking about if it's just x equals? Vertical lines, yeah. So we're going to have a vertical line at -2, but that's going to be what type of line? Solid or dashed? Solid. And then we'll have one at 5, but that'll be dashed. All right, everybody good? All right, let's set it up. Oh my God, I can't use my calculator. I have to think here. All right, so ready? I have a solid line going through -2 on the x-axis. And I have a dashed line going through 5 on the x-axis. And now we got to talk shading, right? Where's the x in the inequality? Guess where we're shading? Right in between, yeah. The x is in between, so we want to shade all the x's in between -2 and 5. There you go. I don't need to label anything. We know where the solution is right here. Don't go on to the next one yet. Don't go on to the next one. I lied. You could do this on your calculator. I tried, but it said error. Anybody know what you got to do, Emma?
Yeah,
Do it as 2. -2 less than or equal to x. Graph that. And then separately do x is less than 5. It'll come up. Okay, so yeah, you got to break it up. If you ever want to do that. All right, if you ever want to do that. Okay. Questions? What do we got? One more? Whoa. Let's talk about this thing before we. Wow. 4 of them. 4 of them on the same graph. Here's the thing. 2's okay. We can do 2 separately, see where the shaded region intersects. If I ask you to do 4 separately and do all that shading with 4 different colors, you know what your darn graph's going to look like? One whole thing colored in. Okay? That's what it's going to look like. And you're going to be like, where the heck is the shaded region? I can't even read my own 4 colors because it's going to look like that. It's going to look like the whole graph's being colored in. And you're going to have no idea where to put the S. So if we have to do more than 2, here's my recommendation with the calculator. Graph all of them without shading. Okay? Graph all of them without shading right now. And then we'll just use our calculator to figure where we should shade for our solution. Right? Because everyone see what I mean. If you try to graph one shade, graph the second one shade, the third and fourth shade, this whole graph will be probably colored in. And you're going to be like, where is my intersection? It's going to be a mess. All right, it's probably going to look like your artwork back in kindergarten, first grade. Let's be honest, right? I don't think did we have any Van Goghs here, first grade? No, just the old what do they call that? Finger painting. How many of you were eating the paste kind of people? Down a couple bottles during your day in elementary school. All right, so let's graph each of them first, and then I'll look at the graph together and see where we got to do our solution. Looks like all these are solid, right? The last two should be very easy to graph. You can use your calculator, but we've been talking today what those lines look like. I'll just let you guys go. Go ahead. Stop your yapping and let's get graphing these four. And then for the first two, at least tell me write down what your intercepts are so I can see a little work. All right, for the first two, let me know what your intercepts are. We have them graphed. Now the question is, can we see on the calculator where all four of them should intersect with the shaded region? Do we see where I should be shading? It's going to be a figure, just not all the way. It's going to be one figure here. Does everyone see where we got a shade? Right there, if I compare it to my graph here, move it up and down to see where all four colors here. All right. Before we end here today, missing something. What am I missing? Okay. How many did we graph? So all but one has to be labeled then. Because look, here's the thing. If you just label one, I'm just supposed to pick what the other three are going to be. So you have to label at least all of them except for one. All right. That's always the rule. Label all except for one. Okay. Sure.
Got it.